Hi, welcome to my channel, The Magic of Math. Today I have a lesson for you on the Pythagorean Theorem. So today we're going to use the Pythagorean Theorem to find the missing side lengths of right triangles. And the question I want you thinking about today as I proceed through the lesson is how can you tell which sides of a right triangle are the legs and which side is the hypotenuse? So being able to answer this question is going to be imperative for you to be successful using the Pythagorean theorem. So let's begin by reviewing who Pythagoras was. He's a Greek mathematician who was famous for his time. He discovered one of the most famous theorems in mathematics called the Pythagorean theorem. And actually a little random fact was the Pythagorean theorem was named after Pythagoras after he had passed away, but they gave him credit for his discovery. So one thing to know is that the Pythagorean theorem is a rule that applies only to right triangles. So this rule, or this theorem, will not work for any other kind of triangle. You must first identify that it is indeed a right triangle, that it has a 90-degree angle. Pythagoras discovered a very unique relationship between the sides of a right triangle. So let's go ahead and look at first a right triangle and understand what makes a right triangle. So first and foremost, we need to have a right angle. And this little box here, you should have seen this before in your math career. That means that it's a little square, meaning it's 90 degrees, because a square, all four angles, has a 90-degree angle. So if you ever wondered why it was a square, that's why, because all four angles of a square are 90 degrees, and we use this symbol in geometry to note that an angle has a measure of 90 degrees. So now we're going to talk about the legs. The legs of a right triangle are the two sides of the triangle that form a 90-degree angle. So sides A and B, those letters, those variables, that's what we use to denote the legs when using the Pythagorean theorem. So if you see a right triangle with variables A and B, you can be rest assured that they're referring to legs. But to be double sure and make sure that somebody who isn't as aware, make sure that they are the two sides that form the right angle. And we call those the legs. The next side, the remaining side, is the hypotenuse. The hypotenuse is the side that is opposite the right angle. So the right angle opens up, and what connects the two legs is the hypotenuse. We always label this C in a right triangle. One other random fact, the hypotenuse C is always the longest side of a right triangle. So it's always opposite the 90-degree angle, but it will also always be the longest side. So now let's move ahead to what the Pythagorean theorem states. It states that for any right triangle, the sum of the square of the legs is equal to the square of the hypotenuse. Sounds like a lot, so let's look at it as our rule. So this equation, this formula, is our rule or our theorem. It states that the side, a squared, one of the legs, sum, right here said the sum, so that means to add, and the square of the other leg. So here are my legs. I'm squaring them. A squared means A times A, and B squared means B times B, and then I have the sum. I add them together, and when I do that, it will be equal to the square of the hypotenuse. So the hypotenuse is C, and C squared is the square. All right. Let me show you why this formula works and what Pythagoras discovered. So when we say square a number, we can also refer to it as the area of a square. We call it a perfect square. So this square has a side length of A by A and an area of A squared. So this orange section represents numerically A squared, whereas it's two-dimensional, whereas this side length is one-dimensional. So the length of A can be represented A squared with a square. We can do the same for B. So notice that I've created a square that is B squared. It would have an area of B squared, and we're going to add on to the side length C by C and get the area C squared. So what Pythagoras said, now a visual representation, is that this square, A squared, plus the B squared must be equal to the C squared. So that's a visual representation of what he's saying. So he's saying if you put these two squares together, they equal c squared. So visually, let's look at this. There's my c squared. I'm going to put the b squared right on top of it. And then I'm going to have my a squared over here. And I don't know if you can see this, but I've divided this into 4 equal sections. So we're going to move one section over, and I'm going to piece the other. There's section 2, section 3, and I'm going to have to turn section 4 to fit in that space. But you can see that there's nothing left over, that it perfectly fits on top. So I have my b squared, and then my a squared I just had to separate into different sections, but it fills that empty part. But together, the square of b and the square of a equal c squared. So that's why it works. And this will be true for any right triangle. So you could actually do this with graph paper. And you could have any size triangle. So sometimes in class, what I have my students do is I'll give them the graph paper and ask them each to draw a different size right triangle. And they all can see that in the end, their triangle proof works. Remember, has to be a right triangle. All right, so now I want you to answer this question. Go ahead and pause if you need to, but I would like you to identify which side of this right triangle is the hypotenuse. If you need to pause, go ahead and come back when you're ready. Welcome back. Let's see how you did. I hope you selected side C. Side C is the side that is opposite the right angle, and that is our hypotenuse. Remembering that A and B are the legs of the right triangle because they form the right angle. But the hypotenuse C is directly across from the right angle. Now I want to show you how to find a missing side. So in this right triangle, which I noticed the right angle is marked, you always want to make sure that's marked, and identify that you have a right triangle because that gives you permission to use the Pythagorean theorem because it only applies to a right triangle. So in this right triangle, I'm missing the side length of C, which is my hypotenuse. It is directly across from the right angle. My legs that form the right angle, my A and my B, which are interchangeable, you could call this A and 7B, or you could call 7 the side A and 24 the side B. It doesn't matter. Legs are interchangeable. The only one that matters is that these are the legs and then this is the hypotenuse. So first I'm going to start, I always start with a formula, and then I'm going to fill in what I know. So I denoted that side A would be 7. So 7 squared plus side B, 24 squared, will equal the hypotenuse squared. 7 squared is 49. 24 squared is 24 times 24, which is 576. So now I need to combine my like terms, add 49 and 576, giving me 625, and it all still equals c squared. But I need to know what just c is equal to. So remember, c squared, the inverse of that, is to find the square root. So I'm going to find the square root of both sides, because whatever I do to one side of an algebraic equation, I must do to the other. But the square root of c squared will tell me the value of c. So 625 is 25 times 25. Therefore, the square root of 625 is 25. So I know that my hypotenuse is 25 centimeters long. Now it's your turn. I would like you to pause the video and find the missing side length. I will give you the Pythagorean theorem because we're just learning, but go ahead and pause. Find the missing side, and come back and hit play when you're ready. Welcome back. Let's see how you did. So the first thing I want to do is fill in what I know. I said that 8 feet, that side 8, was my A, and that 15 was my B. So these are my legs, my A and B, because they form the right angle, and I'm missing side C, the hypotenuse. So now I'm ready to do the math to complete and solve for C. 8 squared is 64. 15 squared is 225. Add 64 and 225, and you get 289. Now I want to know what C is, so I'm going to find the square root of both sides. And that gives me that C is equal to 17. I know it's 17 because 17 times 17 is 289. So therefore the square root must be 17. That is my missing hypotenuse C. 17 feet. Don't forget your units. Now let's look at one that has a missing leg. Solving this becomes a little bit different, just the math part, the algebra part. So we're going to still start with the Pythagorean theorem and identify my legs. So this has to be A now because this is denoted as B. And they form the right angle, so I know those are my legs. So this has to be my hypotenuse C, and it's also directly across from the right angle. So I plug in what I know. Side A is 7, so 7 squared plus the unknown B squared, equals the hypotenuse 11 squared. Do the math. 7 squared is 49, B squared stays, 11 squared is 121. Now here's where it changes. I cannot combine these terms because they're not like terms. I have a variable term and a constant. So I want to get B squared all alone. I want to isolate this on the left side. So to do that, I am going to do the inverse of add 49, and I'm going to subtract 49, remembering that I need to do it to both sides. Whatever you do to one side in an algebraic equation, you must do to the other. This creates a zero pair. So I'm left with B squared, and 121 subtract 49 is 72. So I'm going to take the square root of both sides, and then I'm left with B equals 8.5. Going back to the instructions, it says, if necessary, round to the nearest tenth. So you're going to need to do this on your calculator. Some calculators you type in square root first and then the number 72, and some have you type in the number, the radicand, and then the square root symbol. So you need to identify which your calculator is going to have you do, and then I rounded to the nearest tenth. So 8.5 meters. Don't forget your units. So my missing side, which is a leg, is 8.5 meters long. Your turn. I'm going to ask you to pause the video and find the missing side length A. Again, we're still learning, so I'm going to give you the Pythagorean theorem. Most state assessments give you this on your reference sheet. I think it's more of a reminder to not forget that it exists when you have a right triangle, rather than students not remembering what it is. But regardless, I will give it to you, so please pause and complete your work and come back and hit play when you're ready. Welcome back. Let's see how you did. So I can identify that I have a missing side of A. That is one of my legs. Forming the right angle here is side A and the side that's measured 6. So my hypotenuse directly across from my right angle is 35, and this is my value of C. So A squared, the side B 6 squared, and the hypotenuse 35 squared. I square my numbers. 6 squared is 36. 35 squared is 1,225. I want to solve for A, so I need to isolate this on the left. So the inverse of adding 36 is to subtract 36 from both sides. This makes my zero pair, leaving me A squared equals 1,189. When you subtract 36 from 1,225, you will get 1,189. Final step, find the square root of both sides, giving me that A is 34.5. The instructions here said to round to the nearest tenth. So if the instructions state, maybe they would have said to the nearest hundredth, you need to follow that. If not, then as long as you're following the rounding rules, your teacher should accept your answer. Don't forget your units. This side is in yards. So our answer, approximating, is side A is about 34.5 yards. Remember, we rounded, so it's not exact. If you wanted it to be exact, just a note, you would want to leave it the square root of 1,189. So remember that the square of a non-perfect square is always irrational and will be a repeating decimal without a pattern. So that's my lesson on the Pythagorean theorem. I hope you enjoyed it. If you need a review on finding square roots, then I would ask you to watch a previous video in this playlist. Otherwise, thank you for joining me, and I hope you enjoyed the magic of math. Have a great day. Please subscribe to my channel and give me a thumbs up. Leave me a comment if you have anything to add.